welcome to this fourth lecture in Python training. Last class we looked at Boolean expressions including logical and relational operators, and we looked at different forms of if statement. So if without else, if with else, and a chain of if else if statements. So first assignment based on these concepts is posted on python101.acads.org. So I recommend all of you must go and attempt the problems. The problems are not very difficult because the concepts that we have covered are still very simple. Okay, so if there are any issues with your login or if there are any other issues, kindly let us know so that we can fix them. But it's really advisable that you attempt all the assignments because they will gradually become more and more complicated, and later assignments will use fundamentals from the previous assignments. And another important thing to note is today's quick quizzes I'm not going to host on GoToMeeting because this software does not allow multi-line questions, and I would like to ask questions about programs that I will show. Okay. So if there are any questions about last few lectures, please raise your hand. Otherwise, we will continue forward. So I request you to keep your this acads.talentlms.com site in a browser tab, so that whenever I say, you can attempt the quiz. Okay, so if there are no questions, we will move forward and we will start with a quick quiz, the very first thing. Okay, so everyone please log into acads.talentlms site. If you cannot, then I will also show you the quiz question here. Okay, so please post the answer through private chat. So when you log into Acads TalentLMS site, go to the Python programming course. There you will see quick quiz 10. Please click on that. So can everyone see the question? If someone cannot, please raise your hand. So everyone has to open this site on their browser. They cannot click here. They cannot click the options on go to training screen. So in case you cannot open it, you forgot your Acads login, please send the answer through chat window. Okay, so let me go back to the quiz, and I have it on my web slides also. So the question is, what is the value of this expression 5 less than 2 and 3 less than 0 greater than 1? Okay, so in this case 5 less than 2 evaluates to false, but if you try to evaluate 3 divided by 0, this will lead to a runtime crash or error. However, since there is an AND operator between the two expressions, the Python short circuit semantics say that first part governs the evaluation of AND. So 5 less than 2 is false, and therefore the answer is also going to be false. Okay, so let's look at this in more details. Yes, I got quite a few correct answers on chat window as well. Okay, so what is short circuit evaluation? Short circuit evaluation says that do not evaluate the second operand of a binary operator if the result can be deduced from the first operand itself. So this also applies to nested operators. Okay, so let's take this example. Not of 2 less than 5 and 3 greater than 0, 3 by 0 greater than 1 and so on. Okay, so how does evaluation takes place in this case? So there are a lot of nested operator. The top level operator is this OR. And within that you are calling a NOT and AND operator. Okay, so the way this thing works is, so just 1 second, there is a question about something. Let me. So Sridhar, I have unmuted you. So what is your question?
No, I don't have a question. I was typing something here. I was trying to say whatever is inside NOT will be evaluated first.
Okay. Oh, okay. So you are trying to answer it. Okay. Sorry. Right. So the first part of operand of OR will be evaluated first, and that itself consists of a nested operator. So the NOT part will be evaluated first, as Sridhar mentioned, and within this there is an AND operator. So the first operand of AND will be evaluated first. In this case, we can see that first operand of AND evaluates to false, and therefore the result of complete AND operator is also false. Okay, so it is not going to evaluate second part, which is a potential crash. And because the result of this complete AND operation is false, NOT applied on top of it will give you a true. And as we know, true or anything is true itself. So the OR operator also evaluates to true without even looking at the second argument of OR. So in that case, sense, the whole expression evaluates to true. And even though there are some potential crashes, potential division by zero operators, division by zero operations, the expression itself is well defined in Python. It evaluates to the value true. Okay, so this is how short circuit evaluation takes place. So in general, as we saw in last class and today's class, okay, so there is a question, what happens if the first condition was 2 less than 5? Yes, so in case the result cannot be deduced from first operand, which means if the first operand of AND is true or the first operand of an OR operation is false, in that case second expression will be evaluated. Second operand will be evaluated, and in this case if the first expression was 2 less than 5, the AND will, the 3 divided by 0 operation will take place and it will result in a crash. So you have to be careful in writing the expressions, okay? But at the same time, this particular short circuit evaluation makes writing makes your program smaller than, otherwise you have to keep writing nested if then else, okay? So there are 3 factors for expression evaluation. The first one is precedence, and we saw that precedence is applied when you have 2 different class of operators. For example, plus and multiplication, and, or, and so on. Okay, so if in the same expression you are having 2 different classes of operator, then precedence rules apply, which says, for example, multiplication has higher precedence than addition. However, if the expression contains 2 operators of the same class, like multiplication and multiplication or multiplication and division, then associativity kicks in, which tells you whether the operator associates to right or left. So for example, typical operators evaluate from left to right. You have to first evaluate the left operator, so it will take its arguments and then only you move on to the right operator, which means if I have an expression A minus B minus C, it will first compute A minus B and then only it will go on to evaluating minus C from the result. Okay. However, precedence and associativity typically identify the operands. So what is the operand of first negative sign? What is the operand of second negative sign? Okay. It does not tell you which operand will be evaluated first. So once again, let's take another simple example. A minus B multiplied by C minus D, or let me put them in parentheses. Okay, so what precedence rules tells us, because parentheses at highest precedence, it tells me that multiplication has two operands. One is A minus B, the other one is C minus D. Okay, it does not tell me should I evaluate C minus D first or should I evaluate A minus B first. In some languages this order is undefined. However, Python always evaluates expressions from left to right. So in this case, A minus B will be evaluated first, followed by C minus D. Okay. And similarly, in case of assignment, the rule is slightly modified. The right hand side of an assignment is evaluated before the left hand side. Okay. This may not affect your result if expressions do not have side effect, but the moment we have functions which have some global variables and they modify global variables, we will see that this can affect the result if you do not take into account your precedence, associativity and order rules. So there is a question from Mohit. Yes, Mohit, go ahead.
Hi, Matt. So A minus B in brackets multiplication, C minus D in brackets, we can apply the BODMAS rule, so we know that bracket open first and then perform the division, multiplication, etc. in order. But what if we did not have these parentheses here? What would Python do? I mean, A minus B star, C minus D, would it evaluate?
Okay, so let me just write down the expression. So you want to know what happens? A minus B multiplied by C minus D.
Would it just go in sequence or would it still follow?
No, so first thing you have to apply is precedence. So first you apply precedence and associativity to figure out what are the operands. So in this case, precedence tells me that this will happen first. Okay, so B star C will happen first. After that you have to apply associativity rule because you are left with both negative signs. So A minus B star C will happen second, and third thing is this. Okay. Now in this case you have very clear order of evaluation as well because B star C has to happen first. Okay. But suppose instead I also have B plus D. Oh, sorry. So I have to go back to the original simple example. So the current example, you really have two different things. Two different expressions, B minus C and A minus D. Okay. These are now totally independent expressions. They are part of a bigger expression, but once you identify order of evaluation using precedence and also you identify all the operands using associativity, now these two are two different independent sub-expressions. There is no ordering defined among these two. Okay, you can evaluate A minus D first, you can evaluate C minus D, B minus C first. Okay, And languages like C do not define order of evaluation. However, Python, it says that you go from left to right. And once we come to functions, I will show you why this order of evaluation matters. Okay.
Okay, thank you.
Yes, so if there are no more questions, then we will move forward. Okay, so let's look at quick quiz 11. So let me just enable it. So let me activate all the quizzes so that we can attempt them during the class. So all of you can start attempting quick quiz 11. So this is also based on some hints that I gave in the last class. Let me just put it on slide also. Okay, so once again I would like you to make your best guess in case you do not know what is going to happen. And raise your hand if you have answered it either on chat or on ACAD's LMS site, so that I can figure out everyone has answered it or not. So the choices you have are, I think either it can print launch a missile, or it can print let's have peace, or the program can print an error. Okay. So please raise your hand once you have answered, so that I can see that everyone is attentive and listening to the lecture. Okay, so I got 50% of the answers now. So the answer to this quiz is launch a missile. And again, this will come as surprising for most of the people. Okay, so let me unraise the answer. So if someone has any question, they can raise your hand again. So why did this happen? This looks such a simple thing. So any guesses? Okay, so let me tell you the reason. So as we know that in Python or in any other language, yes, so Sridhar has the right answer. Problem is with floating point representation. Floating point representation, or the representation of real numbers, it cannot be exact in a computer. Computers have limited memory to store data. It could be 1 GB, it could be 4 GB, it could be 16 GB, or maybe terabytes of memory. We are talking about RAM, okay? Or so no matter how much memory you have, you cannot represent all real numbers, because this is the basic mathematical fact that take any two distinct real numbers, there are infinitely many real numbers even between two. Whether you take 0.1, 0.2. Oh, the answer should be launch a missile. I am not, I may have checked the law. So some people got wrong answer when they submitted launch a missile. So that is my mistake then. Okay, sorry for that. Okay, launch a missile is the correct answer. So I will fix that. So on a typical Python machine, there are 53 bits of precision available for a Python float. And therefore, when you are storing 0.1, you are really storing this big binary fraction 0.0010011 and so on. Okay, so even the number 0.1 cannot be stored correctly internally for Python programs in a computer. It is an approximate representation, and therefore if you convert this binary representation into decimal, it becomes 0.1 followed by several zeros and then 555. Okay. So this is the reason why we have two different kind of answers when we write 0.3 directly or when we write 0.3 as directly 0.3 directly or 0.3 as 0.1 into 3. Okay, so this approximation can be thought of as similar to representing 1 by 3, which we will write as 0.3333, and after some time we will give up. Okay, you cannot represent 1 by 3 accurately in a decimal notation. Okay, so no matter how many digits you use, you will have an approximation, and therefore when you do 0.1 times 3, you get a number which is slightly different from 0.3, and therefore floating point comparison gives you an approximate answer, or it gives you a wrong answer in this case. Okay. So the correct answer, I think in the ACADS site I chose the wrong answer. It's launch a missile, and most of you got it correct. Okay. So what to do if we cannot compare floats? So how can we write such a program where we have to depend on two floats being equal? The solution is, do not compare floats as you compare integers. Instead, you use what is called epsilon comparison. Always use a suitable epsilon value depending on your application. It could be 0.1, it could be 0.01, or it could be 10 to the power minus 6. So it should be a suitably chosen small value, and at the same time it should not be so small that or a number which Python cannot represent. Okay, so you have to make sure that the epsilon value itself is representable, and then use a comparison absolute x minus y less than or equal to epsilon. Okay, so this will give you a nearly correct answer in most of the cases if you chose your epsilon carefully.
Yeah, I've got a question.
Yes, please go ahead.
So we saw that if you directly store a floating point integer, a floating point number in a variable,
Right,
it will be approximated. So let's say if you say y is equal to 0.3, it could be stored as 0.301234, whatever. Now,
right,
at the same time, you assign two variables, for example, y and z. Both of them in our code, we write y equal to 0.3 and z equal to 0.3. And then we try and put that in the if condition if y equal to z.
okay.
So what would happen? Would the approximations be different, or would they still be exact?
No, they will be exact. So if you are using exactly same expressions to compute values, the approximation will be the same. Okay, so there is a standard notation for floating point numbers, standard representation. It is called IEEE 754 floating point representation, and that guarantees that the representation is consistent. Okay, it cannot happen that 0.3 for one variable will be represented as 0.31, and for another variable it will be represented as 0.29. However, if you compute 0.3 using two different expressions, let's say 1 by 10 by 3, or sorry 3 by 10 and 6 by 20, in such cases it could happen that you get two different representation. Okay.
Okay, thank you.
Right. So let's have quick quiz number 12 on ACADS website. So I think so you are saying this is wrong. I should have tested it. In fact, it seems I have not even checked the correct answer for this particular thing. It is not showing any answer as correct. So let's go to quick quiz 12. lost it, sorry. So I should be careful. So in this case, you have to compare two numbers, and it's based on floating point comparison. So once again, once you are done, please raise your hand so that I can know how many of you have done it.
I can see the question.
You cannot see the question on ACADS site?
The
Or you want
ACADS
to
link
see
is
it?
not work. I mean, once I'm in the ACADS link, I try and click on any of those quizzes. It does not take me to another link. Basically, the link is not working for me.
So can you refresh once and then check? Otherwise,
Yeah,
I will post the. Okay,
It
so I
appears
will
to be
just
a
post.
static page at this point. I don't know why.
All right. So I will create a new slide and post the question there.
Am I the only one having this issue, or others can access from ACADS directly?
What we can access. So.
Oh, that's strange.
So let me just put the question. Can you see it now?
Yes.
Okay, so it looks like many of you have done. So the answer in this case is, it should be easy to guess. It's the option D, which is float values are represented approximately. And let's just go over all the answers. So part A is clearly wrong because 1 by 3 evaluates to 0.3333 or some representation of 0.3333 in Python. So single division in Python 3 is a floating point division. It is not integer division as in some other languages or earlier versions of Python. Operator minus has higher precedence than operator division. But if that is so, in that case, the answer should be correct. It should be 0, 0 equal to 0 should come out to be true instead of false. Okay. And similarly, if operator double equal to has higher precedence, then our answer will be totally different. So these B and C are not the correct choice. Okay. And similarly, part E is also not correct because Python can represent 0 exactly. Okay, 0 is one number which is represented exactly in all the languages. Otherwise, life will be very difficult. Okay, so the part D is only correct answer, which is float values are represented approximately, and therefore 1 by 3 minus 0.1 by 0.3. Both of them do not give same answer or same representation for 0.3333. Okay, so there is some difference, and you can try this in Python console. Okay, so with this we are mostly done with all kinds of expressions or the peculiarities about expressions and their evaluation. So we will start with the next topic, which is about loops. If there are any questions, please raise your hand now. So I have unraised all the hands. Okay. So next topic is about loops, and this is where things become more and more interesting. And why are loops important? All of us know that, even from our kindergarten or primary classes. Okay, so we are always asked to write this multiplication table, 5 times 1 is 5, 5 times 2 is 10, and so on. Okay, now if you have to do something similar for large number, not up to 10, but let's say 100 or 1000, it's going to be really tedious job. Okay, so if you write a program to do that, and if you write it in the same way as you wrote the table, okay, so this program prints table of n, given n by user, so n times 1 is n star 1 and so on. Okay, so now this is really tedious, it's a repetitive job, and computers are meant for avoiding repetitions or avoiding this kind of job. So how do we avoid it? The idea is you can do some kind of pattern matching. You can find that there is a very nice pattern which is repeated again and again. So for example, what is happening in this case is you are asking for an input from the user and then using a value I, let's say that is 1. And then if you want to print table up to 10, you ask, have I reached the end of my task? Is I less than or equal to 10? Okay. If true, then you will do something because you have not reached the end of the task. But suppose I has become 10 by some magic or by some reason, then you will say, okay, I am done, so I will stop. However, if I is still smaller than 10, then you have to do the task of printing n times I is n star I. Okay. Once you do that, you also have to say that I should go to the next task in hand if there is any, which means I have to increment I by 1, and once again I check whether I am done with my task or not. Okay, so this is the idea behind Python loop. So what we are doing here in this circular region, the region which I have put inside the circle, purple circle, is what is called a loop. Okay, so this includes testing for certain condition, and if this condition is kind of not satisfied, then do certain operations. Okay. The point where we are first doing the test of the condition is called loop entry, and the point when we come out of loop is called loop exit. So Python or any other language in general allows you to create or allow you to use constructs that will make easy to write such loops. So in particular, Python has what is called while loop, which will represent this loop. Okay. So for example, in this case, there is a while loop which tests whether I is less than equal to 10 or not. And if the condition is true, which means I is less than 10, then it will perform the body of the loop. The moment I becomes greater than 10, it will perform the exit part of the loop. Okay. So any questions in this? So please raise your hand if you have any questions. Okay. So let's look at the while statement more carefully. So in Python, while statement contains a Boolean expression which has to be tested, followed by a colon. So this part looks very similar to if, except that instead of if we have a while keyword. Okay, and then you write. Yes, I'm coming to that. So if the body of while should be indented with respect to the while keyword. Okay, so this is also very similar to if. This S1 can be a single statement or a sequence of statements. Python knows where body ends through indentation rule. So S1 is indented with respect to while, S2 is not. So Python knows that body of while ends at the end of S1. Okay. So once again, we have a while followed by a Boolean condition, followed by the body of while which has to be indented with respect to while, and at the end we have some statements outside body of the while. Python allows some other looping constructs like for, someone has asked that, and we will cover it soon after we do the while construct. Okay. So let's come back to the evaluation of while statement. First thing you do is evaluate the expression. If it evaluates to true, then you execute statement S1, and then you go back to step 1, which is evaluation of the expression. So what happens, typically the body will modify the constituents of expression, Boolean expression, and therefore in next iteration it can happen that expression evaluates to false. In case expression evaluates to false, then you directly jump onto the statement S2, you skip over body of while. Okay. So as Anirudh has asked, can we use for here as well? Yes, we can use for, but that will be covered a bit later. Okay, so let's take another example. So in this example, we want to read a sequence of integers from terminal until a -1 is read, and then we have to output the largest number that has been read, including the terminating -1. Okay, so we don't know how many integers will be present on terminal, how many integers user is going to give us, but what we know is whenever we see a -1, we can assume the sequence has ended and we have to output the largest number. Okay. So this is where while loops are very handy when you are not very sure about how many times loop is going to be iterated or loop is going to be run, loop body is going to run. So let's attempt this, and first we will write the loop, and then only we will add code for finding the largest number. Okay. So what do we want here? We want to read an input given by the user. So we are reading the first number into n. Okay, and we are checking whether n is -1 or not. Okay, so even the first input can be -1, so we have to make sure we compare it against -1. If n is -1, we don't have to proceed any further within the loop, we can just exit. But if n is not -1, we have to check next input. So we are reading remaining numbers inside the body of the loop. Okay, so is this program clear? So in this program we are not doing anything interesting, we are just reading inputs. Okay, and then we are checking whether a -1 has been read or not. The moment we see a -1, we are stopping. So let's just trace it once. So suppose user inputs are 4, 15, -5, -1, which can be given in one shot. Or it can be given one after the other as program proceeds. So when we run this program, first thing we read the input into variable n. So n becomes 4. Since n is not -1, while loop will return true, the condition will return true, and we will enter the body of while loop. In that we will read another n. This n is 15. We will do the comparison again, and so on. So next number read will be -5. This number is also not -1, so we will go inside the body again, and finally we will read -1, at which point while loop will be exited. So we will start on some statement which follows the while loop. Okay. So note that there can be many more numbers after this -1 in the input stream. However, our program will ignore that, all such numbers. Okay. So we notice that there is one call to input every time the body of loop is executed. So even though this program, if you read it, it just contains two calls to input, one at line 1 and another at line 4. But due to the execution meaning of Python, the second input is called multiple times, one for each time the body of loop is executed. And every input reads exactly one number. Okay. And then the outer int casts it to integer. Okay. So many times people get confused, how can this program read 4 or 5 different numbers? The reason is every call to input at runtime will result in expecting one integer from the input. Okay, now we have to add code to find largest number. How do we do it? So once again we have to think logically. To find largest number, we need some location to store the largest number. So we keep an integer variable max, which will store whatever is the largest number. Okay, this is where we use it. So what do we start with? Okay, this is also important. So when we have seen just one number, clearly the maximum is the same number. It cannot be anything else. So maximum will store maximum of numbers seen so far during the execution, wherever the execution is, including the including the terminating -1. Okay. So in this case, we'll set max to n. We'll start with the first number set as maximum. And after every iteration or every execution of body, we will check if max is still holding the maximum value or not. If not, we will update it. Okay. So once again, this is a very, very common kind of pattern in programming, that you check for certain condition. If the condition is not true, you make that condition true by doing some assignments. Okay. So at this point we are out of scope of both if as well as while. Note the indentations. So the body of while is indented with respect to while keyword, and within that we have another if keyword, and body of if is indented with respect to if. Okay. The last comment is actually not indented with respect to while, so it denotes that body of while has ended, which automatically means that body of if has also ended. Okay. So any questions up to this point? All right, so let's move forward and have the next quiz. So I will open quiz on my system as well, so that those who cannot should be able to do it. So others, please open the quiz. Sorry, this is not what I want. Oh, we have to go to quick quiz 13, not 12. So you have to look at this program and tell me what will be the output of this program. Okay, so if you have any questions about this end part, I think Prasanna covered it in his tutorial. So once you are done, you can raise your hand. So for those who are unable to get quiz on ACADS, please send a mail to instructor@acads.org so that instructor@acads.com, I think, acads.org, and then we will try to fix this issue, because otherwise doing quizzes this way is slightly troublesome. Okay, so I think what I can do is I can log in as someone else and then, sorry, okay. And there is another question. What is the output of this code? Or what is the meaning of this particular Python 3 code? So I can see some people have done it. Okay, so let me discuss the answers. So in the first case, you are trying to divide number n by 2, and you are doing integer division and then printing n. Okay, so what the values of n in this case will be, say 13, you will start with 13, followed by 6, followed by 3, and followed by 1. However, note that when we are printing it using plus as end of line symbol. So this is something Prasanna told you about in his TA session. So when you, by default, print will print things on separate lines. However, you can change that by using end equal to certain symbol, and in that case things are printed, so things are separated by this symbol rather than new line character. So in this case, output will be 6 followed by 3 followed by 6 plus 3 plus 1, and note that even this last one is followed by a plus sign. Okay, and the other one, so I deliberately, so again I test things, so it turned out to be wrong. So in the second question, we are taking an input from user, and then for every I less than n, we are checking whether I can divide n or not. So n modulo I equal to 0 asks whether I can completely divide n or not. If this is true, then we are printing I. Otherwise, we are just doing nothing and we are moving on to the next I. So as you can see, this is printing all integer factors of n. Okay, it is not printing all integers because printing is happening under an if condition. It is not printing prime factors because clearly we are not even doing any primality testing. Okay. So if there are any questions, please raise your hand. Okay, so let's move on to the next topic. Okay. So with loops, there is certain kind of terminology which programmers use. So every run of the loop is called an iteration. So the body of the loop is kind of static entity. When you are writing code, you will say this is the body of the loop. At runtime, every time the body of the loop is executed, it is called an iteration of the loop. In our example, the loop ran for 3 iterations corresponding to the inputs 4, 15 and -5. There was no iteration after -1 was read because -1 in a way terminated the loop. Okay. There are 3 important components of a while loop. Initialization. So initialization is how your variables are set up before you even test the condition of the loop. So in our example, the first reading of n is the initialization of variable n for the loop. The second component is the condition or the expression, and it should evaluate to a Boolean value true or false. So we are checking whether n is equal to or not equal to -1 in this case. And third component is the update expression. And update expression is very important because it changes values of variables that are used for computing the Boolean condition, or that kind of dictates the termination of the loop. In our simple example, it is the another reading of n. Okay, but in general it can be any expression. I could say n is now 2 times some other variable, or n is 2 times whatever user has given, and so on. Okay, so these are 3 important components. Another important thing to note about loops is what is called loop invariant. A loop invariant is a property over the values of the variables that are used inside loop. Okay, and this property should hold true at the beginning of the loop, and it should hold true at the end or beginning of every iteration. Okay, so whenever your loop ends, one iteration of loop ends, the loop invariant should hold true. Or equivalently, I can say that at the beginning of every iteration, loop invariant should hold true. Why this is important, we will see that. But another important thing to note is within the iteration, it may or may not hold true. Okay, so it can become invalid during the iteration while you are doing some intermediate computations, but it will become true once again once your iteration is finished. Okay, so loop invariant is important because it helps you in proving correctness of the loop, that whatever loop you have written, even this simple loop or in general some complex loop, how do you say that this loop is doing what you wanted it to do? Okay, so for example, in this case, our loop invariant is that max is the largest of the numbers seen so far by the program. Okay, so if you can prove this invariant, then I can prove that my program is correct. It does compute maximum of all numbers seen up to -1. Okay, and you can see that this code which is red in color, it makes sure that the invariant is maintained at the end of the loop. Okay, so in between, just before this red colored code, my invariant might be invalid. At this point, if new n that I read is bigger than max, loop invariant becomes invalidated because max is no longer the biggest number of all the numbers seen so far. However, immediately after this, I fix my loop invariant using this condition that if the number I saw latest is bigger, I will make max as the bigger number. Okay, and this allows me to prove the correctness of the code, that whenever I come out of this loop, n has to be -1, and my loop invariant tells me that n is the largest number, max is the largest number seen so far, and the last number seen is -1. So together all 3 conditions tells me that my program is correct. Okay, so loop terminates when a -1 is seen, and loop body takes into account the computation of max whenever a new number is seen. So together these tell me that my program computes maximum of all the numbers correctly. Okay. So what are some common mistakes that people make? First is many times you forget to do the initialization, or you do incorrect initialization, So this can give you error. You forget to update your variables, and this is a very dangerous thing because it can result in an infinite loop. The loop goes on forever. It never terminates. Okay. To make sure that your update statement is correct, you mentally see that update statement must take the program closer towards the condition evaluating to false. Okay. If you cannot prove that, then there is some issue with your loop. The last thing is that many people forget to put correct termination condition. So if your condition itself is wrong, then you might either exit the loop earlier than you desire, or you might even remain inside the loop forever. Okay, so all three components are very, very important in writing perfect loop. Okay, so let's look at another quiz on Talent LMS site. So in this, oh, sorry. So how do I make sure? So there is no way to retake this test. Okay, so I can't. So I apologize for this issue because somehow it does not allow me to retake the test once I have tested it. So next time I will keep it without testing. Okay, so one thing I can probably do is so this is, so in this case you have to fill in certain values, and for each value you get a choice. So unfortunately those who don't have access to a CAD site probably will not be able to do it. Okay. So it does not even allow me to go to the next question. So let me fill it with you. So this has to be an input, and I have to print all even numbers less than or equal to n. So which means I have to check for I less than equal to n here, and to compute even number I can take modulo 2, and then I have to print the value, and finally I can do I equal to I plus 1. So I suppose everyone should have done it, even though I gave some commentary. So the second question is, you have to read 5 inputs from the user and print the last input. However, this particular code does not produce desired result. So you have to find out the best choice which can have a simplest fix to for this code. Okay. Right, so some people have given their answer on chat, some must have done it on the command itself. So if you have done, please raise your hand. Okay, so I think we can move on. So in this case, the simplest fix is you change plus by a minus. Okay, for any other changes, for example, you can change INP equal to 1 and then INP less than 5, but that requires 2 changes. So there are multiple ways to fix it, but the simplest one corresponds to going down instead of going up in the update condition. Okay, so we can say bad update. I think that should give us the correct answer. Oops. All right, so let's come back to our for loop. So we are few minutes past our time. So if everyone is okay, can we have a 10-minute extension to the session? Well, we can finish by 7:15. Okay. Right. Thank you. So the next thing we cover is for loop. And once again, if you have understood while loop completely, then for understanding for loop is very easy. We will see when should you use for loop versus while loop. There are certain rules of thumb, but in general, both the loops can be used interchangeably. There is no extra power that is added by for loop over while loop or vice versa. So let me drive this to an example. Suppose I want to print the sum of reciprocals of first 100 natural numbers. Okay. So in this case, I know that my iterations are going to be bounded by this number 100. So I will do only 100 iterations. So in such cases, it is kind of more convenient to use for loop. Okay. Again, the reason being, it's difficult to miss out on update step in case of for loop. In case of while loop, many times people miss out or make an incorrect update statement. Okay, so what I want to do is I want to compute reciprocal sum and print it. The reciprocal sum given a number I can be computed as you have to add 1 by I to the sum. Okay, and now only thing remains is I have to add generation of this number I for a first natural number, and this can be done very easily using for loop. So what I want to say is I want numbers from 1 to 100, and for each number I want to add 1 divided by I to the reciprocal sum. Okay, so yes. So any questions? So we are seeing a new operator range, which people who have used other numbers may not have seen it. Okay, so range is a very convenient operator. We will see it very soon, but let's just go over for loop once. So in this case, so assuming range generates values from 1 up to 100, our program will work correctly. So let's look at the general form. So for loop in Python, the general form is that you say for followed by certain variable in keyword sequence. Okay, so we will talk about sequences in details in one of the lectures, but for now you can think about a set of numbers or a set of something, ordered set, so that things get assigned to variable in order. And once again you have the body of for indented with respect to for keyword. Okay, so this is the general for. You have a for keyword followed by a variable which takes values from a certain sequence and then does some operations as part of this set of statements, okay, or sequence of statements. So how does this work? So first you evaluate the sequence to get a list of values. If there are some values, it could happen that sequence is empty, in which case you don't do anything. But if there are some, the sequence is non-empty and you have not processed all the values, then you will assign, then you will continue, otherwise you will exit from the loop. What you do during the loop is you bind the variable to the next value in the sequence, okay, and finally you execute the statement. Okay, so this completes one iteration of for loop. After that you come back and check for more values in the sequence. If there are more values, you continue the iteration, otherwise you exit. Okay, so this is the general form of for loop, and we can see how it executes for a simple example. In this case I am computing the reciprocal sum of first 4 numbers only. So we evaluate range expression and assume that range expression gives you the list 1, 2, 3, 4. You will have to bind I to the first value I, 1, because range expression has given you non-empty sequence. Okay. Then you enter the body of the loop and execute with current value of I, that is set to 1. After that you have more values to process because 2, 3, 4 are not yet processed. So you bind I to the next value, go ahead, execute the body of the loop, and so on. Okay, so you keep doing this until you reach a point when there are no more values to process, because we have taken care of 1, we have taken care of 2, 3 and 4, all of the values. So at this point you exit out of the body and jump to the print statement and print the value. Okay, so this is how for loop is executed. The interesting component in for loop is the function range. Okay, in fact, if you go into technicalities of Python, range is not a function, it is called a generator, but we will skip this technical detail for a moment. So range has 3 different forms. It has a form where you have a start value S, an end value E, and a step D or difference D. In this form, range will generate a list which starts as S and then keeps generating values like S plus D, S plus 2 star D, up to S plus K star D, such that this value K star D, S plus K star D, is smaller than E. Okay, so this is very, very important. You generate value which is smaller than E. You do not generate a value which is equal to E. Okay. So this is very important. Range excludes the end point E. The second variation of range is where it takes only 2 arguments, start and end. And this is equivalent to saying that my step or the difference between successive values is of 1. So it will generate S plus 1, S plus 2 up to S plus E minus 1. Okay, it will not generate S up to E minus 1, it will not generate E. Third variation of range is where you only provide E, the endpoint, and this is equivalent to range 0, E. So it will generate values 0, 1, 2, 3 up to E minus 1. Okay, so these are 3 different forms of range. Another important thing to notice, if for any case endpoint E is smaller than S, okay, S itself, in that case range will generate empty list. So if I say range 0, minus 1, this will not generate any value, it will just generate empty list. So in such cases, if you are using range as part of for loop, it will terminate without even going inside the body of the for loop. Okay. So any questions about range or for loop or anything which we covered, because I'm planning to stop here today. So if there are any questions, yeah.
There is a question on chat.
Okay. So can't we have a decreasing range? Okay. So there is a question that can we have a decreasing range as well? Yes, we can have it. Okay. In this case, you will have your D set to -1. Okay. And let's try it on Spider. So what happens if you have? Okay. So I did not open. Sorry, I did not open Spider window today. So I would encourage you to try it on Spider. Okay, what happens with different endpoints in this case? Okay. So is range a list in Python? So there is a second question. So I'm in fact unmuting people so that they can ask their question. So Anirudh has asked a question, is range a list in Python? So range is really not a list. It is what is called a generator. Okay, so it generates a list. Okay, but as far as the result of the expression is concerned, you can use it anywhere a list is expected. Okay, so we will do some amount of discussion on generators when we come to sequences. So let's, but till that point, you can use range anywhere a list is expected. Okay, or you can treat it as a function which generates a list, which returns a list. Any other question?
Yeah, this is Mohit. I just have a question about the assignments. I'm sorry I couldn't attend the class last Saturday, but I see that there are 3 assignments in Pluto, and I see the end date is October 29th, so the submissions can be done by Saturday.
Right.
Okay, and I just had one quick question. So normally you give some kind of a starting statement in your program. Is it mandatory to keep that for the program to be evaluated by the system? I mean, can I not use that?
No, you can actually overwrite our starting state. If starting state is compulsory, that will be mentioned in the problem statement itself. Okay.
Yeah, the reason I ask is because the first question basically declares a variable as a float. However, when you read the question instructions, the instruction says that the number should be an integer, the input number. So I was just wondering if we can change that.
Yes, you can change that. That is possible. That is allowed. So another thing is that we have certain test cases for you to evaluate. Again, if you do an evaluation, some of the answers will be there itself. Okay, so you will figure out what is the format of output, what do we expect. If there are any doubts, sometimes again this is a manual thing, entering the question, entering the program, and then validating. So we may tend to make mistakes. If you catch any mistakes in our input-output scenarios, please let us know, and we will fix that.
Right, and also one quick question on that, around that is, normally when you enter amounts in real world, you would use the use of commas. So for example, 1000 in the chat window, you would write as 1,000. Now, when I declare, when I try and typecast it as, for example, 1000 int 1000, I'm trying to force it to be an integer. I get an error in Python. The code itself.
Right. So again, once again, this comma is kind of convenience for humans, not for computer. So you may have to write your own processing routine. Okay. So once we do functions, I think this can be a good assignment for everyone. Converting currency from which contains separators into a simple integer. Okay.
Okay. Thank you.
Hey, Amay, I have a question.
Yes.
So you define like range where it will evaluate while S is less than E.
Okay.
Right? But it seems like if you give the D as negative, then
Right.
instead of S greater less than E, it will work as S greater than E. It flips
Greater
the
than
condition.
Right. So that's why I wanted you to try it on Spider and do these variations. And similarly, try giving D as 0. See what happens. Does it go into an infinite loop or not? So these are the things which are very interesting, and you have Python interpreter at your hand to try it. Okay. So I don't want to spoil the fun for people who want to try it. So these are like puzzles, small puzzles. You should work on it. And it's also important to do it because in real world you might have an expression for D. You do not specify it as a constant 1 or -1. Okay. So if for some scenario D evaluates to 0, what happens in that cases? In such cases, so it's that's why I encourage you to try it with different values of D, different values of start and end, and see. Try to justify or try to come up with an explanation for the behavior that you see. If something is not clear, then please ask me and I will be there to help you, or Prasanna will be there to help you. And at this point I will say that TA sessions, we are seeing fewer attendance, fewer people attending TA sessions, but that is where we do lot of practical things. Okay, for example, different formats of range, different formats of print function. It's not very useful to do it in class where we want to do some higher level things. More hands-on thing we will do in TA sessions. And now that we have done some non-trivial constructs, I would encourage everyone to attend TA sessions and even try the assignments, because that will become more and more interesting, or we are at least trying to make them more interesting and challenging as we go ahead. Okay, so there is a question by Sridhar. Sridhar, please go ahead. You have to unmute yourself.
Yeah, Mike.
Yeah, hi.
When I say range 50, comma 2, comma -1 to decrement,
okay, okay,
it printed up to 3, and the last one is not printed. So is it the boundary condition? We have to make sure, like we have to keep in mind that the last one is not going to be executed.
Right. So range is written in such a way, the range function, that it does not include the end point. Okay. So whether you are going in the positive direction or negative direction, range excludes end point. And once again, this will become little more clear when we come to list. So this is done so that you have a more consistent behavior across different sequences. Okay. So range, you can think of it as an open interval on one side. So start point is a closed point, but end point is the open point. Okay, so it's a semi-open interval for those who remember mathematics.
Okay.
Okay, thank you, Amir.
Okay, so if there are no more questions, we can stop here. And thank you for attending. And once again, please attend TA sessions.